All right, so in this video we are going to finish up lesson 2.2 on the derivative, some basic rules of differentiation. So you're going to want to take some notes here. So this next rule is called the constant multiple rule, and it says that if, oh, I don't think, okay, my video is not showing because I have a video for Zoom. Okay, that's okay. The constant multiple rule says if f is a differentiable function and c is a real number, then if you take that constant and multiply it by f, it is also differentiable, and the derivative of a constant is times a function. You leave the constant and you multiply it by the function, the derivative of the function. Anybody, are you writing this down? So an example of this would be, yeah, can move that out of the way very easily. Okay, so let's say I have this example here. F of x equals 5x to the fourth minus 2x to the third plus x. So we're going to be combining a bunch of different rules here. I'm gonna simplify this for the first example, the constant multiple rule, and then we'll do this one in a minute. If you have f of x equals 6x to the fourth power, what you do to find the derivative is you are going to leave the constant, so that's what this is saying. C is a constant in this case. And then you multiply by the derivative of this function here, which is going to be 4. You're going to use the power rule and bring the 4 down in front and then subtract 1 from the exponent, and that is your derivative. You can simplify that and multiply the 6 times the 4, which is 24x to the third power. And eventually you can probably skip this step right here and just go straight to multiplying 6 times 4, which is 24, and then times x to the third. Does that make sense? Yeah. All right, so then this next example in red here requires that you use, let me go back to this rule, the sum and difference rules, which I went over really fast on Wednesday, I guess it was. So this is another one that you probably, I don't know if you got this written down or not, but essentially what the sum and difference rules say on page 111 is that if you have two differentiable functions and you want to take the derivative of two functions that are added together, you just simply take the derivative of the first one and add it to the derivative of the second one. And that works as well for subtraction. You just take the derivative of the first function and subtract the derivative of the second one. There isn't a rule like this. It doesn't work for products or quotients. We have a completely separate product and quotient rule, which we're going to go over next week in 2.3. So this is on page 111, but here's how you put it all together. If you, let's do that example that was in red here. So f of x equals 5x to the fourth minus 2x to the third plus x. So you can extend that to f of x plus g of x plus h of x. This would be like your one function, this is your next function, and this is your other function. So if we're going to take the derivative of all that, f prime of x is how you say that, what would this be? Hi, Keegan. Annabelle, what would this derivative be right here for that term? So you just take the derivative of each term. 5 times.
Or no, not 9. I just had.
Yeah, what? 20. Yep. And if you just write 20x to the third, I don't need to see you write this step out, but that's what you're doing. Okay. Linnea, what's the next one? Next term? What's the derivative of the next term?
-2 times 3x to the second.
Yep. Yes, indeed. And Tegan, what is the derivative of just x?
1.
Yes, it is. So you guys, if you have just x, you can put it as x to the first, and then you bring that 1 down, and it'd be x to the, subtract 1, you get x to the 0. What's anything to the 0 power? 1, right. So the derivative of just x is just 1. What's the derivative of a constant? Do you remember?
You want me to say it or someone else?
You can say it.
Just 0.
It is 0, yes. Derivative of a constant without a function next to it is just 0. Okay. Got it? Okay. I want to, all right, let's look at this. So if k is a constant and you have a function y equals k times pi squared, what would y prime be? Anybody have any idea? Kind of a tricky one. Y prime. Cody, what would y prime be? It's a trick question. Be careful.
1.
Yes. No, not 1. What is it? Close. Almost at
0.
What is it?
0.
It is 0 because, okay, this is the tricky part. Like a lot of people see pi squared. So you want to drop the 2 and subtract 1 from it, but pi is a constant. Pi squared is a constant. If you're multiplying a constant times a constant, this whole thing is a constant. Therefore, its derivative is 0. Okay, so this is the last thing, thing from this section, and that is the derivatives of sine and cosine. So I want you to just watch for right now. This is the graph of, is that the graph of sine or cosine? Sine. This is y equals sine of x. So if you were to draw, I was going to have you guys come up and draw the slope at different points, but I'm just going to do it because we don't have a whole lot of time on Fridays. But what is the slope at this point? What is it? What's the slope right there at that bottom?
-1. Or negative pi over 2.
No. That's the x coordinate and the y coordinate. What is the slope at that point? Think of yourself walking along this trail.
0.
It is 0 at this point, right?
Oh yeah, okay, because it's just flat.
So if I were to sketch the derivative, which you've had to do a couple of times, and you'll have to do that throughout this year, you want to start with your zeros. So the slope is 0 at all these maximums and minimums. And so the red graph that I'm drawing is the points on the derivative, not the bars, but these points correspond with a slope of 0. Okay, now if you look at this graph from here, from pi over 2 to positive in the x direction, from here to here, what's happening with the slope? Is it positive or negative? It is positive, and it is the steepest right at this point. So what happens is that it's the steepest number right there, and actually goes up to the slope right here is actually 1. And you wouldn't necessarily know that from just looking at it unless you really drew it to scale, and you can figure it out that way. But then from pi over 2 to 3 pi over 2, all of these slopes are what? Positive or negative? They're negative. So they're going to go down here, and then it becomes positive again, and it looks like that. What is the red graph?
Cosine.
That is the cosine curve, yes. So the derivative of sine is cosine. So y, and another way to write that is you could say dx, the derivative of the function sine with respect to x is cosine of x. So then let's look at what the derivative of, oh, it's right here. It's going to show you though. if I draw the cosine curve, cosine starts where? At 1. Two pi. All right, so here's my cosine curve. And continues that way. And so let's draw the slopes at different points. The slope here is 0. The slope here is 0. Here is 0. These slopes are all what? Negative, so that goes down, and then it's the most negative right here. That's where it's the steepest. That's called a point of inflection. It's decreasing, and it's decreasing faster, faster, faster. Then it's decreasing still, but at a less fast rate. So it's decelerating is another term for that. And so your graph of cosine, the slopes of the cosine, are the purple graph, which is not quite sine. What is it? Sine starts at 0, 0, which this one does, but then it goes down. How do you make a graph flip over the x-axis? So it looks like sine except flipped upside down. How do you flip a graph upside down? What's the transformation that flips something over the x-axis? Think of parabolas. How do you make a parabola go?
Negative.
Yes, so this is the derivative of cosine. It's negative sine of x. So that you guys need to write into your notes, and then we'll do a couple of problems here, and then I'm going to give you time to ask questions if you've been attempting the problems or to work on problems, one or the other.
Would fifth period be best for you today?
Yeah, I have a feeling I'm probably going to have to do like supervision because there's people on. So I might be in the theater or the library, but you have to look for me.
I'll just come find you.
Okay. All right. So putting this stuff together, if I want to find the derivative of this first one, it's called y prime. What is this going to be? We're going to go around the room. Tegan, what's this term? What's the derivative of 4x cubed?
12x squared.
12x squared. Now be careful. Then what is the derivative of cosine? Annabelle.
Sine.
No.
Negative sine?
It's negative sine, but then it's a negative cosine, so
Positive sine.
it's going to be plus sign because you're going to have minus a negative sign, which is going to turn it into plus here. All right. I was thinking that was 3 different problems. I have it done right there. Okay, so you know what? Let's just start. Let's go over questions if you have any right now.
Happy birthday, Miss Brennan.
Thank you.
Oh, happy birthday.
Happy birthday.
Do you think sometime this year are we going to have the special like fifth period meets too? Or no? Like we did last
Like
year?
when we
Wait,
did
was
8th period in the
Oh, eighth
library.
period, yeah.
You know what time? You know what you guys should be doing. You guys should work together during the 2nd period.
Oh,
do
we
a-
can't work together in the library apparently.
You
Or
could
did they
Most of the time you
change?
can get Mr. Dye to let you get in Martha's room.
Yeah,
He's been nice so far with the seniors.
yeah. You just if you're close proximity, you gotta wear a mask,
Yeah, we did that.
which is hard. I know, but you gotta do it. Especially right
It's
now, I
understandable.
really don't want to go
Yeah,
red.
I know.
Please wear a mask. Okay,
That's
so
really
Linnea, do you have any questions?
Yeah.
I don't think so.
Okay. All right. So you guys go ahead and start working on these problems. Remember, if it's got a if it has like a square root or a radical sign, you got to rewrite it as an exponent. And same thing if it's a denominator. If there's an x to a power in the denominator, bring it up and make it negative. All right. So you guys have your assignment sheet.
I left mine at home today. Do you have an extra one I could just borrow today?
Yes, but I'm gonna go make a copy of it. So
Okay. I'm gonna also turn in 2.1.
Let me just tell you.